Lesson 9.4, Adding and Subtracting Rational Expressions. Now the biggest difference here is obviously that it's adding and subtracting, and it adds a step into the process. So I'm going to start with a simple question of, let's say, 2/3, and we'll say plus 3/5. Now in order to add these, we have to have a common denominator. Now, this is something that we've done before, so let's just review the process because we'll need to know those steps to do what we're going to work on. Now, the common denominator here, I think we would all agree that it's 15. So to make them have a common denominator of 15, I'd take the first fraction times 5 top and bottom. Okay, that would give me 10/15. The other one, I'd have to multiply by 3 top and bottom, and that would give us 9/15. So together, we'd have 10 here, and we'd have 9 here, so we'd have 9/15. Or excuse me, 19. Now I know it's improper, but that's good enough for now. 9/15. And we'll come back to this in a little bit. So a common denominator can also be called a least common multiple, but it's more focused because we are specifically talking about a denominator. So it's a least common multiple for the denominator. So common denominator. Now, if we have a common denominator already, life is good, life is simple, and we just go ahead and add the numerators. So even though we have letters in here, the process is still very simple. We have an answer here. Since you have the same denominator, it is 15mn, and on the top, it's merely adding the numerators. Nothing has to be changed because the denominators are all okay and all similar. So we add them up. But they are not like terms. So we have to also keep that in mind now. And since they are not like terms, all we can do is write 3m plus 5. And that would be our answer. Again, if we were to consider the fact what are excluded values, we could answer that question, but they don't ask us. But if in case we did, we would say 0. So we just would have to plug a 0 in for m and n. That would be considered excluded value, or an excluded value. Next one, same situation. We have a common denominator, so all we have to do is add our numerators. Now again, we're adding, we're not multiplying, so you say, what are like terms here? Well, we have an x and an x, so that gives us 2x. Now again, we're not multiplying, so it's not x squared, we're adding like terms. So x plus x is 2x. We have 6y and a 4y, both positive, so we have plus 10y. And doing so brings us to our last lesson. If you have this finished up now, say, well, look, I have a 2, a 10, and a 24. They're all divisible by 2, so I think we can actually simplify this a little bit. But I do it after I have combined the fractions, or the rational functions. So I notice the top has a 2 in common, so I can factor a 2 out and get x plus 5y. And on the bottom we have the 24x to the 4th, like we already had before. But now I have the ability, since it's times here, to take 2 out, and 2 goes into 2 once, 2 goes into 24 12 times. And our final answer would be x plus 5y all over 12 x to the 4th. And that would be considered simplified. And sometimes that happens when we add or subtract rational expressions. Next one, we're going to deal with subtraction. What's the only difference here? And again, notice we have common denominators, so we can go ahead and write that out. So equals 30k plus 36. And on the top we're subtracting, so we have to remember this. This is a very important part. We're subtracting the second fraction. Now we are subtracting the numerator. And subtraction is the same as adding the opposite. In other words, the opposite of the numerator. So this is actually a negative k and a minus 3 if we distribute that negative. And that's important to remember that second number, the second piece, does change signs also, because that would affect our answer if we forget that. So now when we combine our like terms with the numerators, we have a k and a minus k, which takes each other out. And we have a negative 5 and a negative 3, so negative 8. And again, notice all of those are positive again. So let's look at the denominator and see what we can factor out. I want to write negative 8 over, I know 6 goes into both, so that would leave me with 5k plus 6, okay, which I know now that I can have a 2 go into 6 3 times, and a 2 go into negative 8 4 times, and that would give me a negative 4 over 3 5k plus 6. I don't have to distribute that 3 again. This would be fine. We can take that. That'll be acceptable. And I forgot to mention earlier, I did one of them, but again, what's the excluded value here? Well, it would be whatever would cause k to be 0. That would be a negative 6 fifths. But again, in this case, we're not worried about it. Alright, let's try the next one. We have, again, a common denominator. So 10n minus 30. And again, we cannot add these fractions or subtract these fractions. The bottom is the same, but now notice again we have a negative, which means plus or minus sign, which means plus a negative of the whole numerator, which means we will have negative n minus 1. So 6n minus n gives us 5n, and there's no other like term there, it's just minus 1. So on the bottom, again, just to see, we see that that's factorable, so let's try it and see if it does us any good. Maybe it doesn't, but we'll see. I can factor a 10 out, and that would give me n minus 3. So I have a 10 times n minus 3 on the bottom, and on the top I have 5n minus 1, which are locked together with parentheses. So I can't really cancel anything out because of the parentheses on top. That 5 is untouchable, so we would leave it as is. So I wouldn't really even have to do this if we didn't need to, but it's good to check it to see if maybe you can simplify it further. Alright, so how do we get a common denominator when we don't? Well, again, in the very first page I talked about that right here, and we said, well, we just multiply the bottom by whatever it takes to get that common denominator. And that's what's going to be the same with our rational expressions, but much more interesting because we have letters. So if I were to put this under a 1 and this under a 1 and ask you the same question, what's the common denominator between these two things? I think the 6 and the 4 would be pretty straightforward. That would be 12, because that's the first number that both 6 and 4 can go into. It's the least common multiple. But what about the x's? We have an x and x cubed. Well, I can make the x become x cubed if I multiplied it by x squared, so I can change that. So when it comes to the numbers, it's 12. The variables are actually a little bit easier. You just take the one with the largest exponent. Okay, so that's the common denominator of those two fractions, and in this particular question it also represents the least common multiple. The next one, again, pretend it's a fraction, because this will be kind of more familiar to our prior knowledge, and you say, what's the common denominator? Well, if I look at 8 and 12, what's the first number they both can go into? That would be 24. Then I see m squared, so they both are the same, so that's common. And t cubed. And like I mentioned before, we take the power that's highest. And that would be the common denominator if I made them fractions, but in this case, since they aren't fractions, I'll just say the least common multiple. Now that the next two examples we'll work on part B. Okay, so this is a two-part lesson, so we're going to focus on a little bit simpler questions today. So I have some steps here, but we're going to go right to we've already talked through these, okay? So let me go through this again with you. but I'm not going to go through the steps because we've already actually discussed them. But if I have two fractions here, two rational expressions, or added together. What's the common denominator? Because I cannot add them until I have a common denominator. But there actually is something else we must think about. We haven't done this before, but if we don't have a common denominator and we're going to work towards getting one, sometimes it helps to make sure that each fraction or each rational expression is simplified before we move on. It does help us. We're going to have to simplify first or last, and sometimes simplifying first makes our work a little bit easier. So let's look at each one individually. I have 6x over 5x squared y. Now the 6 and 5 are not reducible, but I do have an x on top and an x squared below. So I could cancel that x out and one of those, which would give me 6 over 5xy plus the 5 and the 3 are not reducible, but again my x's we can cancel, which would leave me with 5 over 3y squared. Now what good does that do us? Well, since we've simplified, we go back to that same question. What is the common denominator? And what we've done is we've actually simplified it a little bit, so we will have a little bit simpler common denominator, that's all. Now if you don't remember to do the canceling first, that's not a problem, but you will be needing to simplify later then. Alright? And sometimes we forget. That's why it's nice to do it first. So here, what's the common denominator? Well, the 5 and the 3, that's pretty straightforward. That's going to be 15. Okay. X and no x. So they both have to have an x for them to be common. Y and y squared. Well, like we said, we take the exponent with the largest one. So that's going to be our common denominator. Now how do we get that, each denominator, to be that 15y squared? So this goes back to that example I gave right away at the beginning. 5 needs to become 15, so I need to take it times 3. That would take care of that. I have the x already, but I need y squared, so I'll have to take it times y. So again, top and bottom times the same thing. That would give us 18y. The next one, we need the 3 to become a 15, so we multiply by 5. We need an x, and it already has the y squared. So we would have a 25, and it's plus the 25x. And this would be our combined rational expression. And notice it's not simplifiable. If I had not taken care of that earlier, at this point we would look and say we'd have to simplify. Alright, next one, we're going to put this over 1 so we can easily see the two fractions. If it's not a fraction, we can easily make it a fraction by putting it over 1. What's the common denominator? Well, this one has everything, and this one has nothing. So, actually just 1. So that's going to be easy. We need to multiply the first one by everything it needs. Okay, now again, before I start, and I was just about to start, so I caught myself, can I simplify the second fraction? Well, the 5 and the 6 are not simplifiable, but the y's are. So I can take away a y from the top and a y from the bottom. Now, I really only need to make the denominator 6x squared y. If I multiply the top by 6x squared y, we get 24 x squared y squared. It's y plus 5 all over the common denominator, 6x squared y. Now again, if I had not canceled those y's out before, I would have to do it now. But we did that already, so we are done. And that would be considered our combined rational expression. So there ends lesson 9.4 part A. Next one we'll deal with more complicated looking denominators.